The material database comes with many default materials, including silicon, glass, air, gold, and silver. Most materials are implemented using the sampled 3D data material model, which is based on experimental measurements of the material refractive index. The source of the data is specified in the material name. For example, Palek indicates that the data is from the Handbook of Optical Constants of Solids by Palek. The material database also includes perfect electrical conductor for 2D and 3D structures, and etch for 3D structures. Etch is the material with refractive index 1 with mesh order 1 by default, and it's used to effectively create cutouts in objects, since the etch material will override other materials that it overlaps. The mesh order property of materials is used to determine which object gets priority when two materials are overlapping in the same region. More information about the mesh order can be found in the link listed below this video. A wide variety of material models are available. You can see the full list by clicking the Add button. The material models available include simple models like dielectric, which lets you set a constant real refractive index over the wavelength, NK material, which lets you set a real and imaginary part of the refractive index for single frequency simulations, and Sellmeier, Drude, or Lorentz materials, which use equations to define the permittivity as a function of frequency. You can also add sampled data materials where you can import data over frequency or wavelength. For sampled 3D materials, the data will be the refractive index or permittivity. For sampled 2D materials, the data will be the bulk conductivity or resistivity of the material and sheet thickness. Sampled data can be used to load experimentally measured material data in order to get simulation results that closely resemble what you would get using the same experimental conditions. There are also nonlinear materials that allow you to simulate gain materials and effects like harmonic generation and optical bistability. The default simulation settings are meant for simulating linear materials, so if nonlinear materials are used, the simulation will require careful setup. There are tips for nonlinear simulation settings in the links below. Conductive material models include the 2D conductive model, which lets you specify the bulk conductivity of the material and sheet thickness, and the graphene model, which takes graphene material parameters such as scattering rate and chemical potential. There's also an index perturbation model, which lets you set up a refractive index that varies as a function of carrier concentration or temperature. See the Advanced Capabilities unit for more details about this. A full list of material models and the definitions of the parameters of those models can be found in the online knowledge base in the related links below this video. On the same pages, you can also find additional material models, such as the step index model and 2-level 1-electron model that you can download.